This is where things get complicated. This elevator is from MKCAD because it's a commercial off-the-shelf part that you could get for your robot. We want to assemble it so that each section slides properly. So we're going to have to use the slide mate. Don't worry about the rope. Grouping all these parts together is difficult, so I took the time and I did all that for you. So, oh, that's right. I can't model in Google Chrome right now because I don't have the extension in. Let's enter this. And I'm allowed to edit this document because I made a copy of it, but because you're using the link to my document, you'll have to copy the workspace. And then you'll be able to edit it. Now, as you can see, I have all these parts grouped in the proper spots. So I don't have to worry about all the parts coming apart. Just these 3 little sections that are already properly grouped. And now we need to mate them together using the slider mate so that they can slide in the right positions. So, let's start. We have the first stage of the elevator and kind of the base of the elevator. So, when we go to our information about the slider mate, allows transition across the z-axis. The first selection starts the sliding point. Now, in this case, it wouldn't really matter because you could either be moving this up or this down. It will look the same. But for good practice, we want to make sure that we do the sliding part first. Let's see. How do we want to do this? Let's select... First of all, let's make this part invisible for a tiny second, just so I can have easier access to the bottom of this elevator. Slider mate. Let's select a part. Let's select the center of this edge. And we didn't attach to anything yet, so it's going to say it's invalid for now. But we'll get back to that part. Where's the part that I hid? Okay, here it is. And we want the mates to start off at the same spot, so we don't have to worry about that. This is 1.25. So let's do a mate connector. We'll select the same point and then just move it. Negative, what was it? 1.25? That's not going to be right, is it? Oh, no, it is. I remembered it correctly. Good job, Casey. Now, we want the mate connector in front of the slide, so we can reference it in our slider mate. And then we just select the mate connector as the other point. Now we can hide the mate connector. This should allow us, oh, forget about the carriage, to slide these up and down, although there's no limits on it right now, and we don't want that. We want there to be limits. But we'll get to that later. First, let's worry about attaching the carriage and making that slide. So we do the same thing, the same general practice we did before. Slider mate. Let's select the center edge of this. And the reason I'm not selecting like this center is because these parts have like this little kind of cavity dip in here, and it's hard to get the center each time. So this is just the simplest way to do it, considering that all these parts are the same width. Let's create another mate connector. Let's slide this above slider. Select it here, and we will have to offset it, or move it. Let's see how far apart these two are. 3 inches. Okay, that's a nice number. We'll move this, and I'll show you what happens if we didn't move this first. We'd be creating these same parts. We could do it this way, but you'll notice when we start off, this will be all the way down here. And then, since it's out of its natural original position, it's harder to calculate how far we should set the limits. So, to save us time and make things simpler on ourselves, we can just align the points so that they are in the same position before we start that. Now, we can use the slider and select our other mate connector as the next part. And this will now slide up. Now, we need to worry about limits. First of all, it's good practice to either fix the base of this elevator, or another way is fastening it to the origin. That works as well. Now, this first stage of the elevator already looks like it's at its lowest position. So does the carriage. So for the slider mate, for this case, because our z-axis is facing down, this will be a maximum of 0. And then our minimum will be how high it goes. That will be a negative value. So let's set our maximum to 0. And we'll do the same thing for the other slider. Now this part cannot slide below here. It reaches a hard stop. But we have nothing set for the upper section. So let's see how far that would realistically slide up. Let's get it close to the top. Let's keep sliding it. Anything happening here? Okay, so this little part right here, this eventually is going to go through. Let me get a good view. This part's going to intersect with this bar on the side. And in real life, it's not going to be able to pass through that piece. So, the elevator will stop when it hits this piece. So let's just do a bunch of undos to get it back to our original height we wanted it. Or we could just drag it all down. It doesn't matter. That piece right now, we need to find out the difference between the height of this and the lowest part of this bar. And, I don't know why it didn't show me the parallel distance. I must have something else selected. 39, oh, drat, what did I do? I selected another part. I just had it. What am I doing, Casey? Come on. Let's do that again. 39.375. That's a nice number. So we can set that as our offset. Because the z-axis is facing down, this case it will be negative. So negative 39.375. That's what we said it was, right? I'm not making that up, right? Okay, I'll check it. Yes, that's right. So now we have an upper limit to this carriage. Yay! Or not the carriage, the first section of the elevator. Now, if you were to test out the carriage and look for a stopping point, it doesn't really... It will stop eventually once it gets to the very top of this. But to make it look pretty, I've just suggested that we set this at negative 35. That way it will look nice. It may not be the actual amount that it would stop at, but it's close to what it would be. And if we wanted the actual stopping point, we could go on to the details of this part and see what the guides for this elevator are. But even if we were designing this, we could make a little hard stop here if we were using this on a robot so that this carriage stops here. So for the time being, let's just say that this carriage only goes up 35 inches. And we have our elevator. Now, there is a challenge to this. Challenge, can you set up the elevator such that it functions in cascade format? And that means when the first stage of the elevator approaches its maximum height, the carriage of the elevator will approach its maximum height, and vice versa. So, instead of these all moving independently, how it should work, when this carriage gets up to the top of its top point, this whole section should be at its top point. And then when I drag this down, when that reaches the bottom of this section, this whole section should be down. And the way we do that is we have to make some kind of relation between these two sliders. And we can do a linear relation. So we can select our two sliders. And we need to have a ratio in here. Because like if I just did this now, it's 1-to-1. So if I were to slide... why is it frozen? Okay. Okay, so we had a difference. This could slide up 39.375, and our carriage could slide up 35. So because we have our first one selected first, when that gets to the top, the carriage should have gone its entire height. So, for one movement of the outer part, 39.375, the inner part should have moved, what did we say? It was 35 inches. So this will be our ratio. And why isn't it moving? That's the main question I have. I think it naturally does it so that it's like a pulley system and they're facing the opposite directions. If I click reverse direction, I think, yes, now we go. Now they're moving in the same direction. So what I had it as before, the linear relation defaults, so it's like a pulley system. So when this goes up, this goes down. And because they're both at their limits here, it wasn't letting it move at all. But now, when I move the carriage or the first section up, they will function in a cascade format. Thus, when this reaches its top, this would be at the top. And when these reach the bottom, this would be at the bottom. And you realize I did do it wrong, because this is at its top, and this is not at its top. And I think what I did is I did the ratio backwards. So instead, we should have 39 divided by 39.375. And that, I'm pretty positive, will fix it. Yay! So now this is at its maximum height, and this part's at its maximum height. And we drag it down. And this is the elevator working in a cascade setup, which you might have depending on how you design your robot. But now we've experimented with sliders, and we learned a little bit about these relationship mates that will relate things so that they move or turn together in a selected ratio. And that is how you would do the elevator challenge.